Alright, you guys should be able to hear me. And you guys should be able to see me. Alright, so what are we doing today? I got a little bit of time. Wife went over to a meeting she had, so I got a little bit of time to hang out with you guys. I figured we'd do some networking, specifically for Linux. This is a primer that I put together for the Professional Linux Users Group a few years ago. Still pretty accurate. I do want to update a few things just because I think there's some things that I could explain better. We'll get through what we can. There's a video of this from back when I did it long ago. Doesn't look like I came up on the Twitch side. Let's see. See if Twitch is running. There we are. All right. So we're going to do this little networking primer, talk through some of the things that I think are valuable for people that want to learn to do systems administration, right? Linux stuff, but there's no Linux machine that exists. I've run, many hundreds of thousands of systems now over the years, and none of them have ever been disconnected from the network. Well, let me say, none of them that were useful wherever. I mean, sometimes we'll build things on their own or whatever, but things are connected to networks. They talk to networks. They got to interact with them in certain ways. So this is kind of a, I don't know, I'd call it like a fundamental thing to understand for systems admin work. A couple tools that I'll be using today to show you stuff will be Wireshark. We'll look at some stuff in Wireshark here, and then Wireshark's free download. And then the other one is the Stig viewer. So the DISA Stigs, which are also free to download. That's the Department of, Information something. But it's DISA Stigs, right? And we'll go look at some of the different things that are out there and the different things these things work. And it's funny, this presentation I've actually been using for some of my college students to show them a couple of concepts from their courses. But this is a presentation I've been giving a long time to the ProLug. And it's just like, understanding the basics of networking. Now, some of you might say, well, Scott, is there like a place I could go to read about it, right? Like, where would I read and pick up some good pieces of information? One of my favorite ones to show you guys is Redbook. There's a Redbook by IBM for networking, and you can go see a bunch of their old Redbooks. And these are all free. They have them all out there free for you. But we should be able to find the network one. If I can't find it, it's down in our Discord, right? Oh, look, there's all of these. Let's go with... see if we can find one of the old... It's from 96. Or from 2006, rather. 2006 is when the one I'm looking for is. Oh, look, they even have one for virtual. Nice thing about the Redbooks is they're free. I don't know. I have it somewhere down in the Discord, but let me pull it up real quick. So in our networking topics, for people that are interested in this stuff, I have some old discussions that I had done on these. But if you're like, hey, where could I go read? I don't want to listen to anybody. I just want to go read it. I don't know. Somebody's probably into that kind of stuff. There's a few. I'm gonna grab the link for you guys. It's not that far back. Not that far. Ah, right here. So here's the Redbook. So I'll pull that up. Drop it here for you guys, and drop it over here for you guys. Boom. All right. So this is what the Redbook looks like, and it's a, I feel like it's not super dry, but it's a pretty good little start for a lot of this. It says it's archived, but the information's still accurate. And then I tell people that want to read it, like, how much do you need for sysadmin, right? If you're going to say, hey, well, I want to be a Linux guy, so I don't want to be a network guy, but I want to know enough. I always tell you guys to read up to right about page 170. 170 is about as far as you need to go to really understand the basic networking stuff, because then it switches over into routing protocols, and routing protocols are how routers talk to each other and that kind of stuff. So that becomes less interesting. And then there's some stuff that becomes interesting again, like some of the IP multicast, and then maybe some of the IPv6 stuff and wireless might be a little interesting too. But mainly to start is that 1 to 170 type pages, right? We're going to touch all kinds of things in the labs here, but All right. So, or in this discussion of network primer, but let's get into kind of systems in general, right? And this is from XKCD, and there's this quote. Actually, it's really funny. This quote came up the other day in one of my streams. I was talking about how things are only magical until we show them to you. Once they're shown to you, they're no longer magical. Also, I have like a bug bite on my arm or something, so now I got to play with it. Anyway, so types of computing problems, and then it's like networking problems are very transient. They can be very difficult, but the more you understand networking, the more you're going to understand to be able to troubleshoot. And at the end of the day, a big part of why engineers are good at troubleshooting is because they understand how things work, right? So if we start to break down the pieces of like networking, it will help you to troubleshoot things that may normally be out of your control. Like, you know, you're a Linux and a systems engineer, but you interact with a network, so you interact with a networking team, and understanding the things that you can see from your side will help you, right? Like understanding, and one of the things we're going to get to here is like, what is the address resolution protocol? Some of you may have typed ARP-A on a box before, and maybe you used it to look up the mapping between an IP address and a MAC address. But what does that mean? Maybe you were troubleshooting and just checking that something was there, right? To see that somebody said, hey, can you check that this value's in the ARP table? And you, yes, yeah, sure, I can figure that out, right? And maybe they even told you the command to run. But what is an IP address, and what's the hierarchical value of it, and what do we mean when we say it's at layer 3 and it's being used by devices for routing? And then what do we mean by the MAC address is a layer 2 static address, right? It's a hardware address that does not change. And what do we mean when we say that this is 32 bits long for IPv4 and this is 48 bits long down at layer 2? And even if we switch to IPv6, even if this changes to IPv6 to be 128 bits, this one still stays 48 bits. And this one never leaves the next hop. Why is that important for me to know? Right? You see some crime show, I always joke around about crime shows, and they're like, we track their MAC address back to their box, and it's like, their MAC address never left their networks, guys. Never left the next hop. The only things that know about the MAC address are the local, right? So it's kind of a interesting thing to look at. Anyway, so we'll be doing like kind of live stuff as we go through it, but then we have these different XKCDs. I always think about things like to get you guys interested in what we're doing. And the idea is that we're taking it from some magical concept and turning it into something that's very digestible for you. That's what I tried to do with this primer. So we're doing our networking primer. For anybody that got here late, this is an old primer I put together. I do want to kind of update this for newer things. Maybe I actually do kind of struggle with like the balance of, I could show you more networking things, but it's like, well, is that really necessary for sysadmin? So this is pretty good for high level steps. So here's the topics. We'll talk about the simple communication model. There's a model that I've been showing students for 17 years now, and that I learned, almost 30 years ago now. And it's a simple communication model, and all communication is built on it. All communication. There's no communication that we know of that doesn't have these 5 components. So we're going to learn that. Then we're going to talk about networking at a high level. Like, what are the 3 types of addresses? And there's really a 4th one that we can kind of add in. Maybe in one of my future presentations, I'll add this 4th type of addressing. But then how and why we subnet, and what does it mean to have these decimal to binary conversions? And if I said that it's that address was 32 bits long, what does that mean? Hey, Paul, how's it going? Paul's back. So is Morrison. Thanks for the Prime subscriptions. Some of you guys know I had taken like 2 weeks off. I just didn't stream for like 2 weeks and just was kind of hanging out. But yeah, we're doing this stuff and we're kind of going through stuff. Yeah, Paul, are you back in Phoenix, by the way, or are you still up in Idaho, Paul? Then we'll walk through the OSI model. We'll just go down through everything. Outcast Wanderer, how's it going? You're still up in Idaho? Okay. It's raining. Paul, it rained like, it was supposed to rain all day in Phoenix today, but it really didn't hit us. And then right at 6 p.m., we just had like a deluge. And it's probably 60. I think it's 60 outside in Phoenix, which is pretty cold for us. Pretty cool. What are we at? Oh, 57 now. Oh, yeah, I was standing outside right now, like with the garage doors open and the wife was leaving. Yeah, it was flash flood. Yeah. I can imagine like some parts of like outside of the city a little bit. Probably got some pretty hard flash floods. It's already like not dry outside, but it's already back down to just normal in my area. But I bet the little canals by us are pretty busy. So, but we'll go through the OSI model. The OSI model is this 7-layer model. It's the Open Standards Interconnect model by the International Standards Organization. So ISO came up with the OSI. I know, super annoying. And there's these 7 layers, and they represent these different things that you kind of should know about if you want to troubleshoot using it. And like what happens at each of the different layers becomes useful to know for 2 reasons. There's always 2 reasons. In engineering, guys, let me just step back and talk like an engineer that teaches engineers. There are 2 reasons for models. One is understanding. One is it's like we can just focus in on the application layer, and I can just talk to you for a little bit about like HTTPS and how that works. And you could go, well, hold on, what about how does the IP addresses affect with that? And I say, well, we're just focusing on this one part now. So it gives you like a layout for like individual components. And then the other part of it is for modularity. And the nice thing about modularity is back to that point of like, if you change out a protocol up here at the application layer, you don't have to change out any of these other protocols at any of these other layers. It would be super weird if you bought like a new network cable and you just wanted to go plug it in, but then you had to like throw away your NIC and you had to throw away your router and get a new one because that network cable was tied to like a specific way that something happened. So it's like that. Life 360 alerts because kids are still there. Paul, actually, the wife asked me, she's like, why? Because I told her that you were up there, and she said, why did he move to Idaho? And I was like, oh, I don't know. I thought maybe his daughter moved up there or something. So I didn't know why you came up. But if your kids are still down here, then he's got adult kids, guys. So they're not like young kids. But anyways, we'll talk about the OSI model, walk through it a little bit, all the way down, which one of these days I'm going to update some of these, but like with the physical layer, I'm going to make them a little more deep, but 24 and older, yeah, so they're all, mine's going to be 18 in August, so yeah. Our grandkid's going to be 5 in February. Old man. I said my grandkid, oh, whatever. I said our, actually, but me and the wife. OUR. My fucking thing. All right. OSI model. We'll walk through it, and I'll talk you guys through like some of the troubleshooting and different things that happen and how much you need to know about it. 2 hours from where you grew up. Nice. Yeah. Smart. My mom's back down here too, Paul. I don't know if I told you that. She's down back in the Phoenix area. So, yeah. All right. So here's our terminal course objectives. Sometimes, like, I don't know, for people that want to take notes or when I originally did this. Oh, you know what? Let me move this down real quick. This is going to bug me. I'm going to move this thing down like that. So you guys can still see your chat, but it's not. There you go. It's not in the way. When I first set this up and we were going to actually sit through it. This, by the way, this is also recorded on YouTube. I did this back 2 years ago when I wrote this. When we're done with this, you should understand the components, the basic components of like networking, from a like systems engineer and Linux admin type standpoint. You should understand why we take big networks and carve them into smaller networks. And the thing that you really want to walk away from with that is what subnets are and how the masking works, because that's what really matters to us on our side of the networking. Us people that control Linux boxes and then connect in. And then we want to understand the flow of data through the network, specifically what we call the protocol data units of each layer of the OSI model. And then we need to understand what the term modularity is. Modularity is the idea that I have like 7 rows across of like Lego bricks and they're all green, and I can pull them apart, take out one layer of green and add a layer of yellow and connect them back together. It's the same exact thing when we're looking at the OSI model. I should be able to switch out any one of those component pieces, and as long as I follow the rules between the 2 layers on 2 hosts and communicating up and down between the layers on any one individual host, everything else should still work. That's what modularity is. Modularity is the ability to treat things like modules, right? Add things in, remove things out, that kind of stuff. So these are our course objectives. Out of scope, not becoming an expert. I'm not getting you ready for a CCNA. We could talk about getting ready for CCNA, right? If you wanted to, but that's not really what this stuff is. Most of the stuff that we'll be doing, again, will be in, some type of terminal like this, and maybe looking at like how the interfaces are set, the route, the commands that kind of have the system show what it can see and how it's interacting. ETH, what's our, right, like ETH tool, and just see what's kind of going on inside of our systems, right? And then the reason a lot of this stuff is super important to understand is because we want to have things interact. Like in my home lab, I have different VLANs that are doing different things. One of them that we just extended last night, if you guys saw the stream last night, we were extending my VLAN across to another node, and we wanted to make sure that that was working properly, and then we got it all to deploy. And because we're doing that, Werewolf can deploy to my nodes with no problems without affecting like my internal home network on the default VLAN, and that kind of stuff. So we're going to get into all that stuff. We'll look at some security around it. That'll be like the STIGs. And I was dealing with this with my students earlier, and I was showing them, like, if you come in here and look at like VLANs, and then you go look at like a VLAN ID. Where's one that's like the very important one here? You can't be using switch ports assigned to an unused VLAN have to be disabled. That's just some standard for secure technical implementation guidelines on layer 2 switches if you're doing stuff for the US government. Now, I tell people all the time, you don't have to, like, outside of like being in a government role, and sometimes I am in a government role and I have to deal with ISSOs, which are information system security officers. Sometimes for you guys, or for when I'm talking with you guys, I'm showing you those, and in the security engineering course we're doing those and we're looking at STIGs, but not because anybody's ever going to come and slap handcuffs on you if you're not doing it. What they're doing, hey Hector, how's it going? I appreciate the bits, keep me motivated. The reason you do it is because it's a good idea. It's the thing I always tell you guys. I have never been, like, in my professional career, almost 25 years of like engineering and systems work, I have never been in charge of people from like a management standpoint. I've been a technical lead quite a few times, probably for the last 12, 13 years or so. I've been like the tech lead. I'm always like kind of in charge of the team, but I have no like inherent or referent authority from anybody. I'm like what we call the technical authority. And the technical authority is the guy you want to listen to so things work. Nobody has to listen to me ever. I sit in meetings and people ask me questions. Nobody has to listen to me. I have no authority derived from like the head of the company ever. Even like passed from a manager to me. Not really. The only reason anybody listens to me for the most part is because I try to know what I'm doing and try to know what I'm talking about. So anyways, we're gonna get into all these things. So here's the course objectives for this little modular talk that we're going to do. All right. And really, I'm just burning time because I have a bunch of labs to build still. I just don't want to build them right now. So we're just messing around, right? Just talking through stuff. So here's the simple communication model. And I love this. Like, I learned this in college, and this is just always stuck with me. These 5 components, there's 5 components here. You can see them, but we can number them if we wanted to. All right. Grab this here. Go light blue. So this is 1. This is a sender. And a receiver is 2. And we can see him right here. There's 2. And then here's 3, which is the message. A packet, right? This is the message. And then it's over a medium. That's 4. And it's always affected by that jerk noise. Noise will always be there. We don't know, as engineers, we know of no noiseless systems, even in a vacuum. When you go to you guys have probably heard this, like when you even go to observe something, you're affecting it, right? So these 5 components always exist in a system. Now, the encoding has to happen, and then the decoding has to happen, but that's part of the message. So we just kind of think of encoding and decoding as part of like what's happening with the message. But even as I'm speaking English here, if somebody were in here that didn't speak English, they might not understand me because I'm encoding in a different way. And maybe if I possibly down like this and talk real low like this, and maybe you wouldn't hear me anymore because now I have made my sending of my transmission is no longer strong enough to adhere to what we'll learn. Well, we don't really talk about much in this, but what's called the signal to noise ratio, right? And the signal to noise ratio is all systems, all transmissions that we can possibly do weaken over time, and that weakening is called attenuation. The weakening of a signal as it goes further and further. So there's an SNR value, signal to noise ratio, in all systems where if the noise gets too loud compared to what you're doing, you can't hear. Have any of you ever sat in a classroom, maybe near the back, and somebody's talking to somebody else next to you while the person's talking towards you from the front, and you can't hear because of the near? It's actually like a far end crosstalk at that point because it's relation to the sender, but near you, you're hearing this louder noise. Or I go and I lecture from the hallway, and as long as it's real quiet in the room, everybody can hear me. But if somebody even starts rustling their papers around, you can't hear me anymore. That's this kind of idea. G. Pike Arch said, I was so angry when I learned math didn't work perfectly. I was instead of sketch that was resolved within continue. Yeah, so there is a fair amount of math. I don't make us do any math in this, but I teach signal engineering. Like some of you guys know me. I'm a classically trained network engineer, and signal engineering was, I wouldn't call it my fascination, but I did a lot of signal engineering in college. So I did a lot with like ham radios and stuff like that. And I still play around with signal engineering quite a bit, and I teach 3 classes on signal engineering at my college too. So like I love signal engineering, and in fact, at the end of this talk, I touch on a few of the things specifically around digital to analog sampling and stuff, but we don't go deep into it. It's one of these things like the strong kind of the way that Professional Linux Users Group, our Prolog, has kind of went, and I mean, this kind of makes sense because it's in the name, is I focused on trying to get people into professional Linux, right? That's been my goal. To that end, things that we kind of put out and build like this are designed to hopefully make people better systems engineers and systems administrators. And that other stuff is more like hobby stuff that we talk about, right? So we have a few guys in our Discord that are at least ham radio 1 level certified and like to do that kind of stuff. So Bluetooth is an interesting one. Yeah, Bluetooth is one of the ones. I actually helped a buddy years ago with his protocol for Bluetooth. He did those little car sensors that would. He had a little. I think he still got the company, but they make little car sensors that would plug in and read data, and then it would send it over Bluetooth to like an app or whatever you had. And I helped him kind of troubleshoot some problems he was having with Bluetooth on that. But I haven't done. So you guys know, I haven't done a lot of signal engineering for the last 15 years professionally, but I did start my career out that way. But this is, at the end of the day, this is the simple communication model. There's a 6th one. Guys, we will add a 6th one for what we call effective. If I could spell effective. Effective communication needs, make those M's. Effective communication needs a 6th one. Anybody guess what that 6th one is? That is a feedback loop. So if you ever see this, if you ever see me, I sometimes draw this out in one of my engineering talks. There's a 6th one for what we call effective communication, which is a feedback loop, not Facebook. But a feedback loop must be there for effective communication because I send to you and you send me back an acknowledgement. But the simple communication model, whether we're talking about ants with chemicals talking to other ants, these 5 things hold. Us talking to satellites and back down with Starlink, these 5 things hold. I don't care what communication is between the cells in your body, between literally, any system that our human brains have seen or heard that does what we consider communication, those 5 components must be there. That's just a simple fact. There's no system that we know of that's simpler that is considered communication. So that's not me on a soapbox. That's just me as like an engineer. And I think that a lot of things become more simple, like to understand when you think of them like this. When you can put everything into one of these components, I think it'll help you when you troubleshoot things. I think it'll help you when you break things down. I think it'll help you This is base engineering right here for me. This is like a thing that I need everybody to level set and understand before we move forward with any of these other parts. In fact, I kind of think as you're talking through this stuff, you should be able to say what any one component is as you're looking at it. So, all right. So here's some like kind of level setting, right? For like things that you'll see me say. You'll see me say TX and RX. TX in this case is not Texas, and RX is not, I don't know, prescription, right? It is a sender and a receiver. And the sender is always transmitting the thing, and the receiver is always receiving the thing. That doesn't matter the type of media that we're using, if we're using physical or free space or air or any types of electromagnetic. It doesn't matter what we're using, fiber optics or copper and electrons and photons. It doesn't matter. And then another one that you might run into in your career as engineers, although more network engineers will use DCE and DTE, and they're going to run into like data circuit equipment and data terminal equipment, which tends to kind of determine if it's on the ISP, Internet Service Provider side of things, or if it's on your side of things, your side of the connection to the WAN. Sometimes these exist within the same component, right? So DCE and DTE. And then when we talk about a clock rate on a serial line, there's always a drum beat. There's always a beat of how fast we can send across that line. That tends to be, whatever the clock rate is what we call the baud, right? BAUD. But not always, but that's typically what that is, right? Then we've got a term that's very important. You'll hear me use this a lot if we're talking networking, and that's autonomous system. And that's everything kind of under my control, my loci of control or whatever you want to call it. And it's this idea that everything that I control, all the way to the edges of my system, are within an autonomous system. So if you could call me up and have me change something, or call me up and ask me a question, and I can get into a box, that's an autonomous system, one of those, right? Everything that I control. Could that be across a LAN? Yes. Could it be across a WAN? Yes. Yep. Could it be something that I VPN in over to and then can configure? Yes. Yep. So autonomous systems are all within one administrator or, company administration, whatever. Demarcation is a responsibility function that kind of exists between the DCE and the DTE. So demarcation is where somebody, you call somebody up. There's always kind of this joke with this where, you call up a network engineer and say, hey, I can't get to this device. And they're like, what's the IP address? And then they ping it and they hang up on you because it responded. What? Demarcation of responsibility is one thing. Demarcation in system speak tends to mean where my autonomous system connects into another one. And where does my responsibility end and the other person's responsibility begin, right? And then a metric, if you ever hear me use the term metric, I just mean a unit of measurement. It's an easier way to say a unit of measurement. So the metrics that we use to determine the lowest cost path for a switch to elect its root bridge to get to the selected root device, the root, I guess is the root switch of the network, and then all the spanning tree protocol traffic flows one way. The metrics that are used are typically speed of the network, and then if it's a value of 4 is like a 1 gig link, and then a value of 2 is a 10 gig link, and then the lower the value the better, so it'll pick between those. There's also 110 meg links, but you don't really see those too much professionally in the last 10 years or so, but probably even longer than that but metrics are how we make decisions. So by the way, I also sometimes people be arguing online about stuff, and you'll be watching them argue, or you'll fly through some social media and see people arguing about stuff, and it's like there's so many reasons people are never going to agree on stuff, but I can tell you one for certain is if both of you were being honest about whatever you were talking about and not just fighting with each other for political reasons, if you were both being honest, the first thing I can tell you about that discussion and that argument or that whatever is if you're not going to be using the same metrics, there's no reason to even talk about it anymore, because you're never going to get to the right thing. And it's the same thing. The reason I say that is not to talk about conflicts from a political thing, but as engineers, if I want to go look at what's going on in a system, and one system's using a certain metric and another system's using another metric, and they're not jiving for some reason, or I'm coming in and talking about a certain thing for speed, like I'm talking about the actual file system throughput, and some network engineer is talking about the bit rate, what system speed is on the network. There's going to be differences, and we have to align our metrics, right? I often talk about that with this is the same thing when you do monitoring. If we're not talking all the same language, we're gonna cause unnecessary headaches, and nobody's ever gonna see eye to eye on things. So autonomous system is better in physical area and scope space, ends the boundaries of some other job. Well, that's a good thing to know. It's good to know where your job responsibilities end and where another person's start, right? When you have to call somebody else out. So, Sourced and Sold, how's it going? I am just walking through. We're doing like a networking primer that I put together a few years back, mainly because I don't want to do anything serious tonight. So we're just walking through. We got down to the simple communication model. Let's keep moving forward. Oh, we were here on network fundamentals. Just some terminology, right? Just level set things that you're going to hear me say, and I don't want anybody to be lost. By the way, this discussion, all of my presentations, of which there are many, are up in the Discord, probably in presentation section. A lot of resource stuff, but down in presentations. I'm pretty sure this is up here somewhere. I'll make sure I'm not a liar. There's my other engineering stuff I was talking about. This one's a little bit older, so it's probably... Yeah, here's our networking primer. So if anybody looks at this and needs it, it's been updated a little bit, but this is generally the same one from back in September, September of 2023. Geez, that's 2 years ago now, isn't it? All right, but anyways, there's three primary types of addresses. There are other ones. There's actually one other one that we'll look at here, but we've got DNS addressing, which at the highest level maps human readable addresses with IP addresses, IPv4 or IPv6, as you can see there. The IPv4 or IPv6 are types of layer 3 addressing, what we call IP addressing or internet protocol. And then the other major primary type of addressing is MAC addressing, which is media access control, happens at the data link layer, which is layer 2. And MAC addresses are 48 bits long, expressed in hexadecimal. Well, we'll go to those here in a second. They're expressed in hexadecimal. So each one of these, like this one right here, represents 4-bit places. And the bits pattern of 1 is 0001 for hexadecimal back to binary. E is 1 less than F. F is 1111, so 4 ones. E would be 1110, right? And you can go find maps of hexadecimal. In fact, a nice way, if you ever struggle, you can pull this little bad boy up, and he would help you with it. So you could go throw this on, and then you go from standard over to like programming calculator, and it would do hex to decimal. So, we can go hex, and then I could plug in my 1, right? So there's my 1, and then my E, there's my 1110. If I need to know what a 4 is, 4 should be 0100, right? Yeah, it's 0100, but I can check that, 0100, right? And then 0, which is 4 zeros. But anyways, my point is you could just drop that in there anytime, and then here you can figure out what these are. That's not super interesting to us. However, the hardware address is interesting to us in that the first 24 bytes, which are right here, first 24 bits, first 24 bits is going to be the vendor portion, and the last 24 bits of the 48 total bits, the last 24 here are going to be just the individual node, right? The individual device. And you can actually take these, and I could take any one of these, and I can go find who the vendor was for it. You can go look them up online. There's all kinds of vendor lookups for MAC addresses. MAC addresses are registered. They're not hard to go look up. But yeah, if you ever get like a MAC dump inside of like somebody gives you some records to look at for some reason, they don't strip out the thing, you can find out what all their devices in their network are that are seen if MAC addresses are showing up in whatever they dump, which is why a lot of times we'll strip information out of system that we're sending to vendors and that kind of stuff. The one other type of address that we run into here, this is actually technically an address, is at layer 4, and that's ports. And ports can be 0 to 65,535, right? 65,535. And those ports are mappings of TCP and UDP traffic that's going to flow between our systems. So let's go look at these real quick, right? Pop this up, got a Linux box. And from this Linux box, I should be able to say something like host www.google.com, and I should see resolutions, what's resolving between that name and how my system is going to get there for Google. I could ping, and pinging Google would show me that I use 172.217.5.174, 147, sorry, right here. Boom. So that's the address that my system used from how it resolved that. So this is a thing that often, like for troubleshooting, if somebody says that one of my servers is not behaving properly or if there's something wrong, I will go to that server. If the network is up and I can SSH to it, I'm like, okay, I mean, the server's up. It sees itself. I'm in the right box. Then I will ping out from there. If I can't ping out, did I at least resolve DNS? Because if I resolve DNS, well, I can check if I have an internally resolved. That's here. Right? This is an externally resolved. So I went out to the world to resolve that name. Right? We can also verify that with like dig, www.google.com. And then if I can resolve that, I know that traffic is flowing. But if I then can't ping, then maybe I might start looking at how my traffic's moving from my system to its the route that it's sending. What's its default gateway? How is it sending traffic out? Where does it know to send things? And we could start to kind of figure out from there, troubleshooting what's going on. But that's DNS addressing. Your primary ways of doing that are host. You can host it. You can dig it. And another one that's big is NSLOOKUP. They give you various different useful pieces of information about getting over there to that system. I have a question that always gets asked in one of my classes to college students. And it's I guess, philosophical question. It's something for you to think about. If my system, when I pinged, just used the IP address here. That's how it pinged, was by the IP address. Strictly speaking, my system does not need DNS. So the question is the internet functional without DNS active? Like if your DNS was down or broken, does your system still work? And that's something for you to think about, right? Because you could say, well, in this case, when I have like 100 users and they're all like grandmas and soccer moms and they're all going to go to Google and look at stuff, maybe that is necessary. But if it's just a bunch of systems that I have that have like host files that aren't going to even use DNS and they're clustered internally, maybe everything's going to keep working. So there's different ways to look at this, right? Is it functional for a human? Probably not. I don't think I've ever had an IP address mapped in my head ever for anything, but I mean, maybe some people might have some of them memorized, maybe, but I don't think I've ever had one like externally mapped in my head for sure. All right, so anyways, there's that. IP addressing, like, what does our system see as its IPv4 address here, and then its IPv6 address over here? I know that's also quite dark for you guys, probably hard to see that. But IPv4 is a 32-bit long address, and we're going to break those down here in a little bit, so you're not going to be super happy with that. The alpaca, that did not come through whatever you put there, but that's funny. We always have 127.0.0.1. Sometimes you guys will see nerdy dudes with shirts that say there's no place like 127.0.0.1. They don't have any cool shirts like Linux is the way. This is my shirt, right? But 127.0.0.1 is what we call home, or a loopback address. So it's even here on the loopback interface. And that allows us to test that the NIC is functioning properly, right? That allows us to see that everything's working internal to the NIC and the system is completely set up. The version of this for IPv6 is a ::1, so just a ::1, and then /128. That is the IPv6 version of home. so the device can identify and test within itself. Our excuse me, network that this device belongs into is 192.168.11, matched at the first 24 bits, which are the first 3 octets, and then /24 lets me know that. That /24 lets me know that the mask of the masked bits, the bits that match, are the first 24 bits of this network. So anything within 192.168.11 is part of this network. This one happens to be .246, which is just in that size network, and we'll see this here in a little bit. That is just a host address. If it was all zeros in that last portion, so 8 zeros, would be 192.168.11.0, and that would be the network name. That network cannot be used. And if it were all ones, which would be 255 in this last octet, it would be 192.168.11.255. That would be the broadcast, which yells at everybody in the environment. So that is how, essentially, how IP addressing works. We're going to break down IP addressing here in a little bit. Our ports are here, and we can see the local address port that we're listening to. We can also see if it's TCP or UDP. That's going to come up at layer 4, whether we are using a connection-oriented protocol or an connectionless protocol, right? And then what the differences are between those. We can see what port we're listening on right here. And if we needed to map those back for any reason, if we needed to map the ports in a Linux box to the ports that they are, we can grep, in this case, like 323 from Etsy Services. This may find some other ones too, but just specifically 323 right here is this RPKI RTR. I don't even know what that is. Resource PKI to router. I don't even know what that port is. I don't know what the heck that's doing. 323. We can go look it up though now. But that's how our system maps it. If you ever don't want to look that up, you can just take this N off of here. And I like to see NTULP because I like to see the port numbers. But you can take the forced, use the numerical, and you can do this, and it'll give you what those are. In this case, it did not map that back. So that's interesting. Oh, because it's UDP. So yeah, so that's not the one for that actually, because it's not UDP. So there's no mapping to this in my services file. But once I found out what that was, what is that? Oh, it's time. So that's 323's time. I could go put that entry into my file if I wanted to, right? Or I could just not. It doesn't really matter. It matters how much you want to map things. But that's our port mapping. 0 to 65, 535. There's what are called the well-known ports. It's 0 through 123 are called well-known ports. There are ports that you don't really use typically for your... If you were like writing a protocol or something, you want to use 0 to 123 because they're the well-known ports. You can use any of the other ports typically. And then again, you can go look at which ones are open and not being used like on Linux systems and use them. There's also a bunch of mappings out there that are available. One of my favorite ones to show people. Does anybody know what port 666 is? Anybody know what that port is? Who has the Doom port? That's for the game Doom, if you guys remember that from the 90s. I always like that one. MAC addresses. And we're going to look at how all these kind of talk to each other. But MAC addresses are assigned to each interface. IP adder. Each of these has a MAC address. And that MAC address is right here. 368F, 2E, 15, ED, 51. We talked about what MAC addresses were and how they're 48 bits long, and each one of these represented as hexadecimal, right? The numbers 0 through F. And yes, in that context, A through F are numbers. Here they are. Here's the MAC addresses for each of these different interfaces. Mine are, it's actually funny, mine are kind of generic because within virtual environments, they are often generated. But I can see this is P01 Jump 02. If I needed to map these back to like maybe my actual XCPNG system or something, I could come here. Where's my box Where's prod? Here's P01 Jumpo 2. And I can go to his networking and I can see 368F2E15ED51 is right here. That's network 0. So I can look at these devices very quickly and see that I do not have a VLAN tag to any of these interfaces. Excuse me. If I go to my Werewolf server and do that same thing, I would see very quickly that I'm on a different network for one of these, and then I can go look at that network. I know this is a lot of stuff, but Lab Internal is on VLAN 1, and that's how I actually segment my systems off. We'll get into VLANs in a little bit here. 802.1q tagging in a frame that allows us to, it makes kind of like channels. So VLANs are virtual local area networks, but they exist in a network, but they're virtual. Well, how do they work, right? And that's a thing that people always wonder, like, wow, how do they work? Well, by tagging that 802.1q, we can say to any switch in the network, don't allow this to leave this switch port unless the switch port is allowed to let that frame leave. That's how it actually works. And then that frame would never leave, and it would never go communicate with something off that switch. So the switches are the keepers of VLAN tagging, right? Because that happens at layer 2. But we'll get into that here in a little bit. That's not really necessary to know yet, but we're looking at the MAC addresses. MAC addresses must be locally unique. Within the network, they must be unique, because when the systems go to communicate, and there's a process of ANDing of bits, which we'll look at here when we get into the networking. But what they do is they look to see, okay, 192.168.11, if I'm number 246, there are 253 other addresses I can talk to. You might say, Scott, hold on, there's 256 total, so it's 255. And I would say, no, because you had to take 2 away, right? It was 256 minus 2. The 2 that went away were the network address with all zeros and the broadcast address with all ones. We'll see that here in a little bit. But just suffice it to say, if my box wanted to talk to another server and that server was on 247, he would come here and he would say, okay, I'm on 192.168.11/24, so my network, I would AND his network against my network, and I would see that he's in my same network. By seeing that he's in my same network, I can talk to him via his MAC address. I can send my device. Now, is it still going to be put in a packet and still have his IP address? Absolutely, but it's going to actually be using the MAC to get over there. It's the devices are going to move it over there without it ever having to go to a router, is my point. But that's not true if there's a VLAN in the way. If there's a VLAN in the way, then we have to go up and come down through a router. Always true. If you have a VLAN involved, it always has to go to a router. That's because only a router can move between them. All right, we'll get to all that because we get there. So let's talk about this binary thing. This is what I was just talking about. So this is a model I love to show students. I love to show you guys. And this is a quick binary rundown. Let's use that address we were just using. So we had 192.168.11.246, right? That was my address, and it was /24. Do we all agree with that? The thing that we have to do, and I always start at the beginning with this. That's 192. I always start at the beginning with this. The first thing we need to do here is understand the classes of addresses that we might run into. Yeah, Paul, this calms me down after dealing with college students for sure. Actually, my college students are pretty easy for my online stuff, but let's look here. What's the class of address? There's also there are 2 other ones. There's a class D and a class E, but you won't run into them very often. So, whoops, I did not mean to do that. Okay, so looking at this, if 192 is in the first octet here, and here's the ranges, 0 to 127 would be a class, well, it's really 126 for class A, and then 128 to 191 and 192 to 223. Is this a class A, a B, or a C address? We know it's a class C, right? So if it's a class C, it's got 24 network bits by default, meaning that we can't touch anything to the left of this. These are 8 network bits, 8 network bits, 8 network bits. And in this address, because it's a /24, we have 8 host bits. That's how we have. We don't have any subnets in this address yet. We're going to start carving them up here in a little bit. And actually, I have to add to this presentation variable length subnet masking because I only show you fixed length, but that doesn't really matter. And we got this 192, and we We know it's a class C, so by default, that's where we're at. That's what's given. These network bits are ones in their mask. So ones. And this becomes useful because typically when we have to give the system, when we want to give like a device, a Cisco device or our system, we can't always use the /24. In modern Linux, you can just use the /24 and it'll take it. But in your Cisco devices, you still have to type out the mask. So what's the mask? If these were all ones, and here's our binary conversions over here. I'll show you this here in a second, but this, if they were all on, this would be 255. And if these were all on, they would be 255. And if these were all on, they would be 255. And if these were all off, they would be 0. There we go. All right. Now, real quick, I'm going to ask this because I typically will jump over this. Julius Caesar said yes, but we just need the IP address. Your system would find the IP address with ARP, and it would put it in there, but technically the devices are still communicating over layer 2. I think that's a question from earlier. I might have missed it. Real quick, looking at this, does anybody here, and I'm just going to ask this real quick because I always wait to see if people want to know, does anybody here need a quick rundown on the powers, the base elements of like a numbering system, a 2-base system or a 10-base system? Does anybody want to see that? I typically just show it anyways, but I mean, does anybody need to see that? Or does everybody understand how this binary thing's working? Because I'll show it. I mean, I got nothing better to do until the wife gets home. Anybody want to see that? I said anyone want to see that, not you might want to see that. I think people should want to see that, maybe. But let's just do a quick rundown real quick. All right, we got one yes. I always go with what I see. Let's say I was talking about money real quick. Let's talk money because everybody understands. If I put this number up here, I put a $sign in front of it, and I said I have that many dollars in my pocket. Everybody here understands. Does anybody want to write that out, like what that means? And not just 537, but how much is that? Does anybody know what that is? Look, we're going over it, Code Reader. I was just asking if anybody wants the base numbering real quick. So we intuitively know this because we deal with money all the time. Yeah, G's right. It's 5 100s. It's 3 10s and 7 1s. That is a good way to write it. I would have also accepted the words $537. But why is that? Well, because we've got this numbering system that goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 states of nature. So there's a 10-base numbering system. There are 10 digits that could be in any of these. And this is 10 to the power of 0, this is 10 to the power of 1, and this is 10 to the power of 2, and it'll keep going out to the left. So what is anything to the power of 0? Well, this is the ones column. And anything to the power of 1 is itself, so 10 to the 1 is the tens column. And 10 to the power of 2 is the hundreds column. So when we look at that, because we can have 10 states of nature, 0 through 9, I can have 5 100s, 3 10s, and 7 1s. And that's something a lot of you probably learned pretty early on, but you maybe never thought about it, right? So look at this real quick. If you all intuitively understood the $537, and then I just broke it down for you and showed you the states of nature, down here for binary digits, we can only use 0 and 1. That's all we're allowed to use. It's off or it's on. It's like it's 8 light switches in a row flipped up and down. So the 2 to the power of 0, because it's 2 states of nature, 2 to the power of 0 is the ones column. If this is on and these are all off, it's a 1. The number up here would be 1. This number happens to be 11. Well, what would 11 be? 11 would be 0 here, 0 here, because there's no 128s in 11. There's no 64s. There's no 32s. There's no 16s. There is an 8. There's an 8 and an 11. Leaves you 3 left. And there's no 4, but there is a 2. So now that's 8 plus 2 plus 1. That's 11. That's it. Guys, that's all it is. So then if we were to break this down, we've got 192. So I take, does 128 come out of 192? Yeah, it sure does. So we turn that bit on. Then I have 64 left over. This is the 64s column, so that's on as well. So that is 192 in binary. Now we got to do the 168. Is there a 128 in there? Yes. 128. That leaves me with 40. Is there a 64 and 40? No, right? No, of course not. But is there a 32 and 40? Where am I getting those numbers? Right here. Yes, so there's a 32. So now there's 8 left over. Is there a 16 and 8? No. But is there an 8 and 8? Yes. No 4, no 2, and no 1. So 11 is right here. There's no 128s, no 64s, no 32s, no 16s. There is an 8, there is no 4, there is a 2, and there is a 1. Now this number is 246. That's a big boy. 246 is a 128 right here. 128. Then we got to subtract, right? Boom. Boom. That'll be 13, right? And then we've got an 8. And then that's, what is that? Oh, we didn't have to do it. But we have to subtract the 128. And hold on, sorry guys. Like my brain's freezing up. Did I not? My brain has frozen, guys. I can't do math today. Somebody do my math for me. My brain's broken. Why did I don't know. Is that 118? I don't know, guys. My brain's not working today. Yeah, it's 118, right? So then, is there a 64? Fuck it. I'm losing my mind. Yeah, now I gotta do that. So then there's 4 and there's a 5, but yeah, that has to be on, right? And then there's a 54, which is there's a 32 in there, right? So take a 32 out. It gets a little messy if you longhand this, but then it's 22. There is a 16 and 22, leaving no 8, but there's a 4 and a 2 and no 1. So that's 246 in binary. You could also use your calculator. There's also a million calculators online. But I think when you're first learning it, it's good to kind of longhand it and understand what these breakdowns are. So that is a quick binary rundown, right? That is like a quick way that we do this, okay? I pretty much showed everything here, but I didn't show this and I didn't show this yet. But these calculations will become important here in a minute. So that was a quick binary rundown. Let's go to why we subnet. So in that example we just gave, 192.168.11.0 with a /24, that is a big network like this. And for my own home network, that's perfectly fine. I can have that big range and everybody can be on there. But let's say that I was a college professor, and I am, and I'm standing here like this. And I want to yell at my little college students, and they're sitting in their chairs like this, right? They got the little chairs in front of them. And this guy's got his little chair in front of him. He's sitting down. Boom. Right? They're very unhappy. But they're getting yelled at by me, right? And when I want to yell in this big open room like this, I have to yell down here at 255. But if we had another college professor, real quick, take this same thing here, and we had another college professor down here, let's say, like Dr. Marzouk, one of these professors that I work with, and he's yelling at his college students down here, and they're sitting here, and they're very sad, right? They're sitting at their little desks, very sad. And when he goes to yell, he also has to yell at 255. So my students hear him, and his students hear me, and we yell at each other. And we're yelling, and all the systems are hearing all the systems. So the story goes like this. You're given a network, 192.168.1 in this case, and it's a big address like this. And I'm over here yelling, and they're over here yelling, and everybody's talking over each other. But what if we wanted to carve that up? So we borrow one bit from our host. So now it's no longer a host bit, and that bit becomes kind of our room delimiter. So over here on the left, these are like the rooms. 0 and 128 are the networks, or kind of like the room you came into to get to my class. And I'm somebody on that network. But now when I yell at 127. It's almost like, you guys ever seen those big like ballrooms, like Crescent, I don't know, there's a bunch of hotels that have like big ballrooms downstairs, and you can rent them out for weddings and parties and seminars and all these things. I'm sure you guys have been in them. There's like a big Orange County Convention Center, and they're all over the country, right? And so 0 to 127, this is like you put the big wall dividers up, right? And now one side can be over here and one side can be over here, and they can be talking. But now for me to talk to everybody in my network, I yell at 127. That's what's known as my network and my broadcast. And now Dr. Marzouk, let's just use him as an example because I've worked with him for a long time, 128 and 255, he's yelling down at his students in this other room, this other network, and he's using 255 to broadcast. And that's right here. /25, you borrowed 1 bit. Let's borrow 2 bits. You borrow 2 bits, and now you have 4 networks that are 1/4 the original size. Now we're using fixed length, FLSM, fixed length subnet masking, where every cut precisely carves them down by the number of bits. So it's going to be always precisely the same size. In variable length subnet masking, we can do different size rooms. But for now, this is fine. He and I are still, I'm now yelling at a smaller space. And he's in a smaller room, but yelling at the same one. And then we can carve this even further. We can borrow another bit. And now we've got 192.168.1.0/27 with 8 networks, all 1/8 the original size. 0 to 31, 32 to 63, 64 to 95. Now, I want you guys to remember these numbers. We'll come back to these in a second. I'm about to do something that is either sorcery or mathematics. Now, I don't have anything up my sleeves, so I'm not trying to be, a magician of any type here. I'm about to carve this network up on the next screen. And if you remember these numbers, we'll come review them. But it's going to work the same way. So I say let's break down that /27. So 192.168.0.1. 192. I don't know what's going on with my Tuesday. 168. I think it's because it's the end of the day. I worked all day and then I taught 10/27. So we know it's a class C because it's still a class C. So we know that we can't touch anything to the left of this. And for all intents and purposes, there's no reason to even talk to anything on the left anymore, especially if we were doing I tell my students like Network Plus or CCNA type certifications. 192.168.1 is going to be in every answer from now on. We're only breaking down over here now. It's a /27, so we borrowed 3 bits. Those bits are right here. Now, hey Robodom, how's it going? Hopefully this stuff's useful to you. I haven't seen my mod Robodom in a while.
Hello.
So let's suffice it to say real quick, though. Let's look at what we have here. These are 24 network bits. Here's 3 subnet bits and 5 host bits. Now you say, how did you find that 5 host bits? I know how you got the network bits. They were given. And I know how you got the 3 bits that you borrowed because it's 24 to 27. There's a difference of 3. But where did you get that 5? Well, there's an equation right here. If we're using an IPv4 address, there's always 32 bits. If you count these, there's 32 of them across. So network, which is 24, plus subnet, which was 3, plus host equals 32. So you would subtract the network and subnet from this side, and that would leave 5. Host equals 5. That's how you would do it. Simple little algebra, right? So then I got this rule right here. Network bits get 1s and subnet bits get 1 because they're network definitions, and then host bits get 0. So we would have a whole bunch of 1s here and a whole bunch of 1s here. And it's no longer that original mask. Now there's a new mask in town. There's a new mask for this network. So if we were to carve our network up this way, our devices would have to take that new mask, which would be 255, right? Because all those on will equal 255, 255, 255. And then this one is going to be 124 plus 64 plus 32, which happens to be 224. There's only a few states of nature it can be, right? There's only a few things it can actually be. So 192.168.1 doesn't change. Now let's look right here in the subnet bits. Let's count these up. Let's mess with these real quick. If I were to count all these up and figure out how many there are, there's 000, 001, 010, 011, 100, 101, 110, and 111. There's 8 of them. I just counted them up. 1, 2, 3, 4, 5, 6, 7, 8. Now I could have also 3 bits. How many subnets do we have? We have 8, and we know that because we counted them. But what if we had a whole bunch of subnets? That wouldn't be very conducive to count. We got this equation down here, to the power of s. So there's 3 subnet bits. Here's 3 with how many states there are is 8. So that is 8 up here because we have 8 possible totals. Now, this is counting right here by the 32s column. So if we were to take these networks, if we were to turn all these host bits off, we would have these networks. We would have 0, we would have 32, we would have 64, we would have 96, we would have 128. By the way, they align right here. There's 0, the first one. There's 32. There's 64. There's 96. There's 128 right there. 128 in that column. Here's the next one is plus 32, so it's 160, 192, 224, and 2, 1, 2, 3, 4. I didn't skip any, did I? And then 1, 2, 3, 4, 5, 7, 8. Yeah, there's all 8 of them, right? And then now, if we were to turn all those host bits on over there, so all these host bits turn on, you would get one less than each of these. So you'd get 31, 63, 95, 127, 159, 191, and 223. And then the last one would be 255 because it's all the bits on, right? Because they would all be on and all the host bits would be on. So real quick, I want you guys to remember that 0, 32, 64. They're all the numbers right there. That's the ranges. The ranges are found by counting these bits right here. And they're right here. You're essentially counting by 32 up the network. And then they're networks when all the host bits are 0, and they're broadcasts when all the host bits are 1. Network, broadcast. It's not magic, guys. It's all simple breakdowns. Now, you might say, Scott, do I have to do this longhand every time? No. This is just when you're first learning it, right? When I'm first like explaining to you and we're like breaking it down. All right, so that was a good question. So Julius just said, what's a mask? Sorry, I missed that. So let's real quick break these down again, 192.168.1, and I'll show you why the mask is important. So 192 was 11000000. If you wonder how I did that, 192 is a 128 plus 64. 168 is 1010100, and we know that from breaking it down a second ago. 1 is just right here. Now, the question was, and this is kind of funny how this works. The question is, what is a mask? And a mask allows you to AND bits. ANDing is a mathematical process. Now, it's also a logical process, so this will be fun. I'm gonna tell you guys a story real quick. I'm gonna say that yesterday I went to the park and I went to the mall. Does everybody got that? Scott went to the park and the mall. That's what I tell you. I went to the park and I went to the mall. Now, you find out a few minutes later that I didn't go to the park. Did I lie to you? Like I'm your significant other. And did I just lie to you? Sure did. Because you went to one of the places but not the other, right? And I said and. I went to this and that. So and requires both of them to be true for it to be true. Well, when we and bits, it's the same way. So look real quick. There's 2 ways you can think about this. You can and the bits, or you can think about the mask as like a platform. I don't care how you think of it. It's however your mind works. But let's find where this 192.168.0 address is when we AND these bits and figure out which of these networks it's in. Does that sound fair? So what we would do is we would AND these bits down. So this would be 1, 1, because this is on and this is on. This is not on, and this is, so this stays off. So you can AND bits like this, or, I mean, if it helps you mentally, think of this like a platform and think, well, these are going to stay the same. So this is 192. This is 168. This is 1 because they're the same. And then over here, these are going to stay the same because they're 0. So it's 0, 0, 0. All those are zeros, so anything else would have fallen off anyways. And then you would say, well, what network does 192.168.1.0 belong to? It belongs to the network 192.168.1.0. Let's do another one. Let's say the number, for fun, was 37. So we would have 192.168.1. Those aren't going to change. But what is 37 over here? 37 is a 32 with no 16, no 8, and then it would be no 4, but it's, I said 37, right? So there would be a 4. Sorry. Whoops. 37 would be 32 plus 4, and then that would be 36, and then no 2, and then a 1. So this would be right here a 37, let's say. But these would fall off. So over down here, we would only have the 1. So the network for 37 would be 192.168.1 dot, and these fell off, so it would be 32. So the network for this host address, 192.168.1.37, would be 192.168.1.32, and your system would find that by ANDing the bits. These bits, you say, why did all those bits turn off and just go back to the network? Because there's no platform for them to stand on. These are true up here, but they're false down here. Right? Does that make sense? Over here is like a platform. These all stay the same. But over here, since these are all off, they all fall off, even if they're active or not. So that's why the network is just these bits over here. Host bits become, host bits don't have a mask under them. So they automatically go to zeros, and then that's how your system finds, by the process of ANDing bits, what the network it is on. It basically strips off anything over here, if you want to think of it like that. You can think of this as a platform. You can think of it as stripping off anything in the host area, however you want to think of it. But the process is this. It ANDs the bits. Is this on and this on? Yes. This on and this on? Yes. This is not on. You lied to me. You didn't go to the park, but you did go to the mall. Still lied. And that's a truth table, right? True and false with ANDing. So it's a logical thing, but it's also a mathematical thing. But that's how your system finds where it is. So, real quick, let's look. This is very dry, right? Watch this. In my home lab. Let's go to, I don't think Werewolf's a good example. I think my home box is a pretty good example. So let's clear this up. Clear. Get out of there. IP adder. And then, yeah, look at that. I got some Docker addresses. And then I say IPR. So route. All right. So I want to send, so check this out. Here's my routes. And I like them because they got a lot of different ranges here. And I want to send some, so I'm on 192.168.11/24. So this 245 falls off as far as network goes. We only care about this. Let's say I want to send to 192.168.11.11, right? Well, I would come down here to my traffic, and we would see, my system would determine the route based on the address, right? New World Andy, how's it going? So we go right here, 192.168.11, and we're going to try to match that down here. So does 169.254.0, and actually it's a /16 matching, so it only matches these first two. Does this match 192.168? No, silliness, right? How about 172.17? Doesn't match. That's silliness. Add a /16, so matching the first 4 bits. How about this one? This one's 192.168.11/24. Yeah, that's the way my device would go. Out that interface, ETH0, which by the way is the interface that's on. So you might almost go, well, Scott, that's silly. There you go. Boom, it found it right there. Okay. How about 192.168.122, which is some internal network that I have /24. Nope, I don't match anything there. But what if I wanted to send something to like 172.17 dot anything? Anything here, anything in this range would map and go out my Docker interface. So this box can run Docker images, has a Docker range internally that it can talk to. Julius Caesar, yeah, the masking of the net. Yeah, so masking is a way to verify the network for your device by ANDing the bits. That's exactly correct. And these numbers here are shortened length strings of ones. So in this case, you can look at this as a 24 is 8 bits, 8 bits, and 8 bits underneath this, and it makes this network. The network portion of this address is 192.168.11, defined by this /24 string of 24 ones. That's exactly right. But if this was a /27 like we were just looking at, then this would be 192.168.11 224 would be my mask for this network. The 245 would be my host address, but my network would be the 192.168.11.224. I would be in this range between 224 and 255. Visually, it's really easy to see. It's like right here, right? 245 would be like right here. Visually, it's very easy to see, but the system doesn't see visually. We can only deal with this, right? So that's exactly how ANDing works. That's why it works the way it does. Yeah, so the first 24 bits are network. Yes, that's exactly right, Julius Caesar. Yep. The /24 means, boom. And this /24 means look at these 24. There's 24 bits represented there, 8, 8, and 8. We call this dotted decimal notation. Each decimal represents 8 bits, so the states of nature is 0 to 255. Look, this 172.17 is mapped at only 16 bits, so this is a /16. It's a 255.255.00. It only matches this portion, right? And now I'm getting over into routing here, but the point is, this is how the decisions are made for this. If my system doesn't have one to match, it uses the default, which is where it was going to go anyways. So it would go there if it had no match. If you don't have a default route in any Cisco router, any routing device that I know of, and any routing table for Linux, if you don't have a default or a gateway of last resort, then your system will just drop it on the floor. It won't do anything with it. And that will stick you in the Linux world if you don't have default routes set up. In fact, let's go to SSH to Auto 5. When I first built all these, devices, we did not have a default route in them. So this default route I added. I can show you guys how I added it if anybody cares. In the overlays. So in our overlays, when we were like rendering, let's render one of these so you guys can see it. This will be, we're going to cat out one of this if configs for Rocky. Let me see. Will this do it? No, that just shows that. I need the one, where's the file at? Hold on. Here's the route. So I want you guys to see how I set those static routes, because they were not there by default in any of these images. So I have down here at the bottom of this, there's a default. This is a default route, 192.168.11, internal to my home network. If these devices need to get over there, they can do that via 192.168.11 200.1, which is the internal C router device. I could actually pull those out, and then none of these devices would be able to communicate with my home lab anymore. Or the home lab would no longer be able to communicate with my internal devices, which, could be good for security reasons and that kind of stuff. They wouldn't have a route to get over there unless somebody knew how to set that up and get over there. So, okay. So that's why we subnet. That's kind of how we subnet. And guys, networking in and of itself, nobody learns this overnight. There's probably like 2 or 3 people on planet Earth that just pick this up the first day and go, I know it, right? I've been doing this for 25 years, right? Like networking side of things. Linux for about 22. And the networking side of things might take a while to settle in. If you guys need this breakdown, like if you need the charts and stuff, I have it up in the networking section of our Discord. They're free. You can go get them. I used to do little challenges for people to work through them that wanted to, so you can find some of those up in the Discord. I haven't done one of those in a while. We don't always have a lot of interest because, again, going any deeper than I'm showing on networking probably isn't really necessary for like a Linux sysadmin. So networking engineers, for the guys that I train for network engineering, like at the college, they got to do this and more, and they got to keep digging more and more into this. But we do interact with networks from our Linux side, so we do need to make sure our devices are configured properly. Otherwise, the networking team's just going to tell us to go kick rocks because we don't know how to program our shit. They might tell you it's a /27, figure it out. But again, modern Linux will take that, but your Cisco devices don't. So you still got to go do this, 255, 255, 255, 224. All right, so let's talk about the OSI model. This is a high-level model. Wifey, are you home? I have to yell for the wife sometimes because she can sneak up on me, and I don't want her to sneak up on me. There's the other day she just like walked in the room here, and I didn't even know she was home. So I thought I heard her. That's why I yelled for her. But anyways, let's talk about OSI model basics. This is the application presentation session transport network data link physical model. They are numbered from 1 to 7 that way. And it's the Open Systems Interconnect model by the International Standards Organization. So the OSI made the ISO, or the ISO made the OSI, and it's just silliness, right? But this is a great model. I actually prefer this model over the TCP model. There's a 5-layer model that I prefer the 7-layer model. Also, if anybody cares, I preferred the 7-layer burrito that I don't think they make anymore at Taco Bell. I preferred that thing too, but I don't think they make it anymore. Anyways, all right. Yeah, Dev said, what does anding bits mean? Anding bits means that you test this bit and this bit for truth, and then it only stays true if they're both true. So anding bits, real quick, right here, when you and bits, if this is true and this is true, which they are, it stays true. Is this true and this true? Yes. Is this true? No. And this true? No. So it almost logically creates a platform where 192.168.1 will always be this portion of the network. That's why I draw that line. And then here, if it was like this is now portion of network over here. And when we had a 37, the device was 001.00101. But its network, when we ANDed the bits, its network became 32. So 192.168.1.37 is in the network 192.168.1.32. That's its network. And we found that by ANDing the bits and taking these ones away, because logically they go to 0. That's all ANDing is. Excuse me. So the OSI model is a way to learn. There's basically 2 things. Jerry said, for Linux admin engineer, do I recommend NetPlus or CCNA? No, I don't think you need either of those, strictly speaking. I had a CCNA when I got into the industry. I came out of the Army. I had gotten, when I was an infantry guy, running around with my rifle, but I got a CCNA. I couldn't tell you what a router, or I couldn't tell you what a server was. I could program the shit out of routers and switches, but I did not know what a server was back then. It's actually kind of funny. So for Linux admin, I don't think you need either of those, but if you're just trying to break into the industry, I always tell you guys, any positive differentiator is good. Anything that just makes your resume look a little better, and you will interact with networking as a Linux person, as a Linux admin, Linux engineer. You will. I deal with networking all day. In fact, I still program routers and switches, but I just do that because they need me to on my supercomputers. But here's our OSI model. There's 2 main reasons for the model. One is for teaching, because now I can focus on each individual area and say, we're focusing on this area. And the other one is modularity. I should be able to change transport layer components without changing anything above them or below them. As long as we're talking with transport and we are using TCP or UDP as we should, and we are using the right port numbers and allowing a connection back, all the communication should occur, right? Now, I mean, but this allows us then to troubleshoot if we understand how each of these components are working and how the layers talk down and then talk across. So really, this next one is kind of the one that's interesting for us. Between host 1, the data flow down, getting more and more information applied to the front, and at only the data link layer, only at layer 2, there's data that are applied at the end. Then the flow of bits go across the physical medium, whatever the medium is that's picked. The typical ones that we deal with are some type of copper with electrons. That can be unshielded or shielded twisted pair. It can be coax still, those kind of things. It can also be fiber. Fiber is some type of core with cladding around it, and then that core, through that core flow protons. Those protons tend to be either laser emissions or just light, simple light. And then the other one that we tend to have is free space signals. Free space signals tend to be electromagnetic, right? So electromagnetic is both the electric and magnetic generation of signals down a line and then sent across free space, right? And we could break those down and talk about all that stuff. I don't get heavily into that in the physical part of this, but like if people want to talk about that up in the Discord and want to deal with like signaling and all that kind of stuff, there's all kinds of stuff here. But suffice it to say, much like our simple communication model, each layer needs to talk to the other side in the manner that that system expects it to be, right? So bits, if we're talking, if we're using copper on one side, it better not be something else on the other side for the most part, unless there's something in between that's translating them for us. And we do have gateway devices, and gateway devices do change things, but that's not necessarily germane to this part of this, right? Yeah, the OSI model. I love teaching to the OSI model. This is one of the ones, and I had made this claim years ago, and I told the guys I'll do it one day on stream. I'm pretty sure I can talk to this model right here with no other notes. I won't even have notes in front of me. I'm pretty sure I can talk to this model right here for over 10 hours with no notes. Pretty sure. I don't even think that would be hard. 10 hours straight. One day we'll do it. We'll have like a. I don't really do subathons, but people do subathon goals, and maybe I'll do one of those one day, and I'll be like, yeah, I'll come in here and just talk to the OSI model. But then again, that's one of those things where it's not super interesting to my Linux guys. Most of the time, people that are hanging out with me want to do Linux, right? Where Linux is the way, right? That's our thing. Yeah, 24-hour stream talk for 10, sleep for 14. That would be funny. People always try to get me to do hot tub streams, and I'm like, I don't think that would go over well. But anyways, here's the data flow, right? And now we're going to break down for the rest of this talk as we go through each of the different layers. And again, this is high level. I don't dig us real deep in on any of these because this is kind of my primer for systems engineers and systems administrators. So this is designed to be a simple one, right? What happened there? I messed up my router behind SP. Okay. Good. So this is, yeah, so here we go. So at layer 7, high level concepts that you're going to run into is you're going to have HTTP, you're going to have HTTPS, you're going to have DNS. We already talked about DNS pretty heavily, but HTTP is your hypertext transfer protocol, and your hypertext transfer protocol secure, right? These are protocols that pretty much run the internet, right? DNS is pretty much how we always do our communications between these different devices. And then we got a bunch of devices that exist up here. And these devices, strictly speaking, do not only exist at this layer, but they do exist at this layer in some ways. Like a reverse proxy or load balancer may also be based on, it might do like TLS termination, which TLS, strictly speaking, is at layer 4, right? But it could still be a reverse proxy in that it's handling HTTP and HTTPS headers for the backend systems, right? And web application firewalls can protect you. They sit in there. We're going to look at some pictures of those. And then next-gen firewalls are also these kind of like more advanced firewalls that aren't just operating at some of those lower layers. Christmas stream, yeah. Guys, we actually were talking about this. Me and the dudes in the prologue. And we were talking about having, so a lot of times I try to get speakers to come in the Christmas time area, holidays for everybody. And then also in the middle of the year when we do our big, 1 year anniversaries of the group. And one of the things that we talked about doing was having like a little challenge for everybody. Maybe like a weekend where people team up. Maybe we have some people pick some teams. And then give you guys some kind of challenge for like admin type stuff. I don't know. Might even be a heavy werewolf one, because I have some of you guys were here yesterday when I was getting this stuff all deployed in my new Proxmox server, and now that I have the capability to deploy over there, I'm gonna also set up some devices for like Rocky work. They're gonna be in their own VLANs and werewolf work, so people can do werewolf practice, like deploying stuff and building stuff. And I really think that that'll be valuable for people to at least see that kind of stuff work. So, all right, proxy server. What is proxy server? So proxy means on behalf of, and most of you guys are used to forward proxies. So you're used to like maybe jumping in and pretending that you're over in Paris so that you can watch something on Netflix or Prime that you couldn't watch in America, or not couldn't watch in a bad way. I'm just saying sometimes services only have certain things in certain areas, so people will do proxies to jump or do anything like that. Proxy as a forward action just means on behalf of. That's all it is. So we are very used to, having a proxy. People have VPN. People do VPNs, and all they really have is a VPN proxy to go be somewhere else. And again, you hit some proxy, and then you hit the internet, and that proxy is doing things on behalf of you going anywhere else. There used to be Tor. I think Tor still exists, but I think you guys got to know that the government runs over 60% of Tor. Once they hit 60%, they had all the data they needed. So, Paul, I have Werewolf up on YouTube. I have a pretty good little werewolf rundown. So, you missed all the werewolves. Oh, you missed yesterday. Well, yesterday was just me. Maybe it was 2 days ago. I don't remember now. But a reverse proxy does something else. It allows us behind, and this is, reverse proxies have made patching better, system maintenance better in all ways. I mean, it's traffic flow, everything's better with a reverse proxy. But what a reverse proxy does is it allows multiple people to queue up or establish connections to it, and then it establishes the connections back to any number of application servers behind it. So a reverse proxy is often called a load balancer. And most of the time, like you guys that do like F5 load balancing, or you have a front-end load balancer as like an ingress controller from like K8s or something, which we build in some of our labs down in Killer Coda. It's you know, you hit this outside thing, and then this thing handles the connection back. It's useful for all kinds of reasons. At layer 7, it's very useful because it can do reverse proxies can be looking at header information. So it can be looking at actual HTTP requests that are coming in, and it can give, it can do responses to queries out here, so traffic never has to go all the way back. We actually have a model where we run essentially a reverse proxy for like our Prolog, our main website, right? When I went to building everything out that way, you're confused. Ah, I see. There's a lot going on with it, Paul. Oh, hold on, the wife's messaging me. All right, I had to send my wife something funny. All right, so reverse proxies are people are coming in, and then you can control these connections. So I think I have it. No, I don't actually have it here. So I have a whole talk on why reverse proxy. Maybe I need to add this because I think I made this later. So give me a second here. Let me pull this up here. This comes from one of our other presentations, and maybe I need to just grab all this and add it in. But it's, oh, I'm out. Where would I have it? Hold on. I don't think it's in security primer. Hold on. No, that's a different one. Hold on. Is it in cloud something? It's in compute and data security? Hold on. No, not in that one. Hold on, guys. I'll find it. I don't think it's there. I think it's in this one. Nope, not in there. All right. Maybe I don't know where it is, guys. I thought I had a pretty good little... Maybe it's here. It is here. Yeah. So this is the same thing. Hold on. Let me move this like this. Super annoying. But let me get this crap out of the way so you guys can see the talk. Okay, there we go. Let's let me show you guys this real quick. So here's our proxy servers, right, on behalf of. And choose regular time if so I'll add my phone. Yeah, Dev, I try to get on around this time, and it just depends what else is going on, really. But anyways, let's get back to proxy servers. So with proxy servers, there's a thing about what happens with out session stickiness. So you come in and you hit a load balancer and you hit a server, and then the next time you do a request, you hit a different server, and this causes a certain type of problem. This causes the problem that if this server was aware of you having like something in a shopping cart, and this server was the one that was handling it, then you come back in with a request that goes somewhere else, you're going to have problems. You're not going to have that information. And a load balancer in that sense is not great. So a load balancer kind of without session stickiness would be really good if these were serving a lot of static content. They're just serving a basic web page out and nothing was changing on it. That would be great for this. But then maybe we have session stickiness. We put in a session cookie, so once you connect in, you keep going to the same one and you lock yourself in. Now this sounds really good because then you go, well, for my customers always go to the same server. Well, what if there's so now the problem here is now we're locking our resources to an individual user coming in. And I want to do maintenance on this one tonight. So I want to take this server down. Now I got to drain these connections and wait for these session cookies to expire. Well, how long did we set them for? Well, does somebody just have, we're losing data if somebody was using one of those cookies that maybe, so stickiness presents some problems, right? But it does solve a problem, but it presents its own problems in that now with things sticky, I don't have the ability without draining connections out to do things that I want. So like load balancers were great, but then we're going to get into, we could really go into some deep theory here, but we're not going to go too far in much more than this. But stickiness, again, you go to your app and you hit some session and then you stay there. But again, this locks those servers from us being able to do things, or very quick pod resets in Kubernetes sense, right? Like these kind of things. So what did we actually end up doing? Because this is okay, but this was an early kind of way of solving problems. What we ended up doing actually looks something like this. This is a modern stateless system. This is like a design architecture people actually use. A load balancer will be sitting up here, and we're really just strictly talking about load balancers right now, but I want to show you guys where this goes out to. And that load balancer can hit any number of front-end stateless web connections, right? Give some static web content to people. And then those servers, those front ends that you hit, they can talk to a stateless middle tier compute, and that's the application that's running, right? And that application is writing out to maybe an SQS queue right up in AWS. And that queue is then being rendered back to the original front end system, right? Anything that's happening here. And only after things are complete and things have passed whatever kind of queuing and caching that is going on, only then are they actually stored back to like a database. And there's a whole lot of stuff that we can really dig into in like a 3-tier app, right? I have labs to show you guys how to do all that stuff too. But I don't go into caching much, but queuing and storage are important there. So I show you guys all that to say that like reverse proxies kind of open up into their own thing, right? But for us on the system side of things, we care because we can do things to these back-end servers as long as we know how to drain out the connections and we understand the rules, where we can maintain and update the hard underneath servers or components and not have to worry about that. Now it's actually funny, somebody might say, we do it all in Kubernetes nowadays, so it's all just pods. And I go, wonderful. I bet you the Linux admin that sits behind there that runs the Kubernetes hosts is pissed that you just said that, because you don't know what you're talking about. You've got to drain a host to do maintenance on the host, so you still got to do maintenance on a Linux box at some point, right? Does that kind of make sense? So this is still a very important concept, even if you're running Kubernetes, because while you may be using pods over here, they're still on a host somewhere, right? We go kubectl get hosts or get, right? And we can see all the hosts. So proxy servers don't solve everything, but they do make maintenance easier. Firewalls, right? There's a bunch of different types of firewalls to know. There's a bunch of different things that they're doing. There tends to be things called UTMs, Unified Threat Management. They can have multiple layers of security appliances, and they're touching all of these different layers over here, right? Not just application, they can be touching everything. Then we got next-gen firewalls, which are application-level firewalls that are aware of what the application's doing. They can look for poorly framed headers, people doing things that they shouldn't do. They can be, looking at application requests, multiple concurrent connections. So they can be seeing that you're using TLS, you're trying to do TLS to the system, and you're opening multiple TCP half-open, or what we call embryonic connections, and it's trying to just establish a whole bunch of them. It's trying to do the old SYN-ACK attack, where we send the SYN, get the SYN-ACK, and then we never ACK, so you're just holding resources open. And most firewalls nowadays stop that from ever even getting to the devices. Even layer 3 will only allow so many half-open, what we call half-open or embryonic TCP connections, right? Basically protecting our systems. They're protected in other ways too, typically from too many open TCP connections. But the way the old Synac attack used to work is it would be like you were having a dinner party and I would call you up and say, yeah, I want to reserve a place for one. And you'd set out a table, like a place for me at the table. And then I never show up. But I did that a bunch of times. So I set out all the places and then your dinner party can't hold more guests because I used up all your resources. Yeah, Dev. Yeah. I mean, I don't know how many people would do just networking. I mean, I've done a lot of networking stuff with the Prolog, and like everybody always sounds excited for it, but then nobody ever wants to actually do it. So we might do something like that one of these days, yeah, Dev, where it's just like a networking weekend or something. That might be kind of good. And then we got web application firewalls, and web application firewalls, WAFs, tend to be working on WAFs, WAFs. There we go. That's funny. They tend to be working on stopping what are commonly known as like the OWASP top 10. And there's a OWASP top 10 and OWASP API top 10. You can go look those up, just owasp.org. And these are things, sometimes cloud providers like Akamai is a big one. Who else does them? Akamai is typically like a CDN, content delivery network, but they also do front-end web application firewalls, and they can protect your systems pretty well. I've run quite a few systems behind Akamai firewalls, and we were 100% protected when if you guys remember Log4j that hit in 2021, like December of 2021, there's a big Log4j problem, and that was a big one. Sensitive Soul said, is it hard to get a Linux sysadmin job? I don't think so. I think that getting into Linux is all about, one, doing Linux. I actually have some notes on this. Hold on. Because I was doing the streams the other day on this. This was our main focus the other day on Linux. I'm doing something else here, though. I know I got like a million of these. This was getting the job in Linux admin engineering. So I have a couple of streams on this. But really, what I told you guys to do was go do a self-assessment and see if you really want to do it. Because I think a lot of people think they want to do this. But then when you literally sit here all day, every day, I don't know. Some people just can't do it. And I'm not like trying to crap on anybody's parade or anything. I'm just telling you, some people, this will drive mad over time. They can't look at a black screen with white or green letters all day. If you can do that, then I think you need to learn some Linux skills. Maybe you do a lot of Linux. People do Linux, but what are the admin? What do they want you to know how to do, right? Well, they want you to be able to do documentation. They want you to be able to do incident management, troubleshooting. This is where actually from an actual job. We were looking at Linux admin jobs. They want you to understand monitoring and operating the system and patching the system and configuring it and automation maybe. And they ask you about all these things, and I think that you need to have skills in all those areas. And then you need to get together a resume, fit it all into one page if you can, lead with what's asked for by a specific job, and then you need to practice interview skills. We actually sometimes practice those. We haven't practiced those in a while with anybody, but we'll do like questions and give people time to work through, and with other people watching them so they can get a little bit of that, that worry and that kind of stuff. And then I say put in for jobs, look for stuff that's remote, look for things that are local to you. I don't think it's unattainable for people. I definitely think that you can get the job in Linux if you want. We have a whole Discord that tries to teach people how to do this. The Discord has, we could go into it for a while, but there's the, let's just go to prolog.org. Is this up? Yeah. Let's go to certify. And then I wonder if the books have changed. So here's the course books. So this is I'll link this to you guys that need it. But yeah, Robdom, thank you for giving everybody the Discord. And here's the course books repo. Is that the repo? Why is that going to the repo? Hold on, they got it here. I think they have, where do they have this? Why Prolog started? Maybe, they have it here. Sorry, this is my bad. Here's the qualifying. Got to do all that stuff if you want to do. We have little certifications that we do. They're all free, but you do got to get in there and do it if you want to do it. Where the heck is... Okay, here's the Linux one. Maybe there's the current deployment. All right, so here's the different books, and then you can find the books, and they walk you through the worksheets and the labs and all that stuff. There's a lot of stuff going on in our little group. But yeah, I think you guys can do this. I think you guys can definitely do this. Said, do you take a cert? You don't have to take a test for those. You just have to go through them with us. It takes 10 to 16 weeks, depending. You gotta write in our Discord. You gotta do there's all kinds of stuff. Like, there's a lot of work. I think it's about 8 to 10 hours a week of work for you guys. Yeah. But yeah, if you hop down the Discord, there's a section. I'll show you guys, anybody that wants there. In the prologue, beginner start here. This is where the current books are. Oh, here's the current book. Yeah. So here's the books. Do I have... And then here's the playlist for the automation course, which is running now. We're going to be going into Unit 8, but I'm going to have to kind of level set and run. I got to record 6 and 7 and 8. So I'm reordering them, and then I'm going to record them all coming up. But 1 through 5 is already... So we got an automation course going. Security engineering and system administration are already done. So for people that strictly want to get into Linux systems administration... That's what this is. But that's all up in Discord. That's all free. You guys can do that all you want. We're strictly speaking right now talking about systems. So we're talking about networking, right? But web application firewalls. And then here's a model. This comes directly from Amazon, AWS, right? Amazon. And maybe you have like a web application firewall in front of your stuff, and people are trying to get in, and they are being managed by... There's a bunch of rules that can be there. There's allowed and denied lists, and that can be dynamically set. There's SQL injection, so looking for in API calls things that are problematic. There's cross-site scripting attacks and HTTP flood attacks. And then just a bunch of things like scanner and probe, making sure people aren't just running stuff through your system. There's reputation lists. So there's a bunch of IPs out there that are mapped back to like crypto mining and all this other stuff, and some of those will automatically be blocked from trying to communicate with your systems. And then bad bots are bots that are scanning your network in ways that you don't want. Now, it's interesting because my buddy Jared sometimes comes and talks to the group. He works for a pretty good sized web company called Zorro. He works for a company called Zorro, and they're online, and they have $1 billion a year website. I think they're about like 1.1 billion now, and they do sales of kind of like Grainger products. If you guys know what Grainger is, they're these basically like everything you could possibly need for your office. Like, oh, you need a new one of these little like arms that holds all your, all your microphones for like 1,000 people. They got them. And they got them in 17 different colors, right? Grainger just has like all these offer products. They sell big, or they give you these big, I actually still get them, big catalogs of just all their parts and part numbers and stuff. Well, anyways, there are good bots and bad bots. Jared tracks bots. That's what he does with Google Analytics. And good bots come and scrape your information and your web pages and do queries and purchasing from like trusted vendors. So sometimes from trusted IPs. Sometimes they're not from trusted IPs, but they're doing activities that you expect. And then there's bad bots. There's things that are just coming and scanning your network and walking around and not listening to like your robots.txt file and like all these different types of things. So, so there's a bunch of, excuse me, things like this going on. And as the things are coming in, there's always logs. Those logs are going to like a Kinesis data fire hose, feeding over to an Amazon S3 bucket. Maybe you're doing automated Amazon Athena queries against it to see what's going on. Maybe you're doing some Lambda functions to block things and do all this kind of stuff. Maybe the web application firewall goes to CloudFront, and then CloudFront or an application load balancer then calls an API gateway and does Lambda to kick off something. There's all kinds of things. Guys, this is like a simple one, but there's a million. There's a thing called the well-architected framework, which is a nice way if you're getting into there. Zoho? No, he works for, no, he used to work for Zorro, but it's, he works for, what did I say? Whatever I said, Jared. No, Zoro is what it is, Zorro.com. That's the company I'm thinking of. Zoho is a different one. He used to work for a different company too, but anyways, Jared's a data architect. He does like analytics and stuff. A bunch of ways to see this stuff, a bunch of things that can be happening in here. The point of this isn't to make you know what all these things are, right? We could dig into each of them, but the main thing is a web application firewall is in front of your system, protecting it based on these different things. One of the ones I tell you guys that's kind of funny is I was working at a big insurance company. I used to be their red team lead. And for some reason, guys, I don't know why this fell like this. Red team should not have been running the web application firewall, but we were. So I was in charge of the web application firewall. And a problem came in one day where a bunch of stuff was coming through, and the stuff that was coming through got flagged and blocked, but it was from one of our trusted senders. So we went and looked at it, and it was like SQL injection. The hell, this is a trusted vendor of ours, and they are sending us, what they were sending us was an API call of a bunch of bank names and credit bureau names and stuff, because we were an insurance company. It was a bunch of things that we could take payments from and this kind of stuff. So we were getting all these errors, but it's like from a vendor, like we trusted this person, but our web application firewall was like, no. So we looked through the data, right? We looked through, it's a bunch of JSON data coming in a page, and the banks were called like Credit Union First and like Select First Credit Union, and they were these names of like banks. Like if you guys have ever seen a bank or a credit union, Select First whatever, this and this and this, and well, so this particular one that I'm talking about right now was an Akamai firewall. So it was an Akamai firewall that was doing SQL injection. But just think of those bank names: Select First Credit Union, like whatever these are. Well, Select is a keyword for SQL. Union is a keyword for SQL. Yes, so Select is one. Union is one. Anyways, there's a bunch of them, but the point is it was flagging these, so we had to go and block those as keywords only for that particular one, so we could do that down on our firewall. But yeah, I've used web application firewalls in front of stuff from. I've had some on-site ones that I've used, and then I've also used the Akamai one. The AWS one's fine. I mean, they work fine. There's a couple of different price models on them for people that are interested in that. One of the things I tell you too is not just with web application firewalls, but another thing to understand, and this is a good one. I think AWS has a pretty good talk on this, or a little thing for people that want to dig in a little more. Find this best practices here real quick. This is a deprecated doc that I'm going to send you guys, but it's still the right. See, hold on, let me see if I can find. Oh, maybe this one isn't deprecated. Let's see if this one still has that other data in it though. Hold on. This is one, but this is not the one that I want. I'll still link this to you guys, but this is not, it's not the one that I'm thinking. Well, I'm gonna still link it to you guys. This one is actually nope, not that one. Where'd it go? Oh, it's over here. Hold on. Pull this back up. This is the. Let me find this old. I feel like AWS. They probably, it was unpublished a while ago, so it was archived, but I don't see it. But they had a pretty good, just basic DDoS, not the resiliency one. But just, it told you what DDoSing was, and it just explained to you, kind of for people that want to know. You can look it up, AWS best practices for DDoS, and they have a pretty good little talk on. Well, just there's some pretty good tables that talk about what each of the layers of the OSI model got hit with, and what the attacks look like, and what you kind of look for in the network, but. Web application firewall, fine. It's good for your layer 7 type protection. There's other things we can do, particularly with our load balancers. We can terminate TLS there, and that will a lot of times mitigate a lot of pressure that can come from too many connections being established to our like application type devices. All right, so what happens at layer 6? There's 3 things essentially that happen at layer 6, which is the presentation layer. We encode on one side, we decode on the other. We compress on one side, we decompress on the other. We encrypt on one side, we decrypt on the other. So, encoding and decoding. This can be, Well, there's all the formats so of media. So this is like your MP4 formats and those kind of things, and that's encoding and decoding. That's also compression technically, right? This is also for encoding and compressing. This is also your what we call codecs. So if any of you guys ever work in any voice, if you ever do any voice type stuff and you compress down streams for, I think one's like GS or G711 or something like that. I can go find it. I have some voice over IP calls recorded. Is it here? Where do I have that? It's up in SIP. It's all real-time transport. What was I thinking? Oh, maybe I can't see it there. But anyways, what codecs we're using, and then encryption and decryption can be whatever types of encryption and decryption you might want to do at that layer. But this is what happens. And the main thing to remember is whatever you do on one side, you have to undo on the other side. So if you encrypt things down, you got to decrypt them back. What is going on over here? Turn that off. Okay. Whatever you do on one side, you got to undo on the other. So layer 5 is windowing and flow control, and these are only in relation to TCP. Windowing is how many before an ACK. So how many can I send before an ACK? And then flow control is changing the window. Right? So changing the window is your flow control. We don't do a lot in the networking side of things at either layers 5 or 6. There's not too much going on up there, right? But then we get down to layer 4 and we start to get into, so we can dig more into these, but honestly, it's not super interesting to us from the system side of things, right? Getting into the layer 4 protocols is really where we start to troubleshoot a lot. There's a lot going on down here. It's kind of important. Let's see how far the wife is too. All right. So we have TCP and UDP, and it's actually funny. I never wrote what TCP or UDP meant. So TCP is your transmission control protocol. I couldn't think of it. And then user datagram protocol, right? TCP is connection oriented. So there are 3 things happening in a connection. There's a establishment of the connection. There's a transfer of data. And then there is a breakdown of the session afterwards. Now, I just want you guys to think about this for a second. For connection-oriented protocols, let's say that you were, think of either your favorite movie as being like you're one of these Pirates of the Caribbean guys, or you're like a Star Trek guy or Star Wars guy. I don't care, whichever one you want. Is there any other way that you can get from one ship to another, either in space or in water, where you don't first throw your hooks or first connect, establish that connection, then move the people or whatever across, and then, presumably break down at the end when you're done? Is there any other order that those 3 things can happen and that would work? I mean, you just start launching people off into space and it looks like an episode of Rick and Morty. All the people in the Citadel that weren't acting right get kicked out into space, right? Because the authoritarians there, right? That would be if you didn't have an establishment first of a connection. You're just launching stuff off. And then if you don't break down the session at the end, then I guess we just keep communication open forever and there's too many resources. So connection-oriented protocols, they are very much controlling things. And UDP is just shotgunning them over the network. UDP is just shotgunning. It doesn't care if it gets over there. And you might say, yeah, but there's things that can tell. Yeah, that's happening at higher layers. Typically with UDP, we're just launching stuff over and then On the far side, after it gets up to the top, there's error checking and those kind of things, and then comes back. In fact, you might even think, as you learn that there's connection-oriented and connectionless, you might say, well, what is something like this? Like, I'm doing a stream here to a bunch of people, you know, presumably around the country and maybe even some other continents. What do you guys think that would be used, TCP or UDP, for voice and data and your meetings and all that kind of stuff at work? Well, it might surprise you, if you don't know, that it's all UDP. It's all done via UDP. It's all connectionless. Because TCP is still going to be like establishing connections and doing all this other stuff and getting data acknowledgement and all this other stuff, where with UDP, when we're doing voice, if you're ever doing voice with somebody, if a packet ever, at this layer it's a segment, but if it ever arrives 1/6 of a second late, it might as well just be dropped. Because it would cause so much jitter inside of your head and inside of your ear that it wouldn't even be worth it to have anymore. So 1/6 of a second is under 100. It's 166 milliseconds, right? Would be a sixth of a second. Yeah, 166 milliseconds. So if it arrives after that, it's not even worth having. Well, I can assure you, with some of these distances and connection-oriented protocols, you're going to have some problems in that space. So UDP is the way that we do almost all voice over IP and almost all of what's called real-time transport protocol, or what used to be H323 protocol. There's two protocols that kind of govern all that, and you can kind of see that. Oh, wife's home. All right. So if I didn't tell you all what I just told you, which one of these do you think has more overhead? This one or this one? So this is the source port and destination port. They're the same length. Source port and destination port, same length. And then there's a sequence number, an acknowledgement number, and a date offset, and a reserved. And then there's bits for if it's an ACK or a FIN or a SYN or whatever. Windows, checksums, urgent pointers, option date, all this stuff. And this one is just nothing. Which one do you guys think would have more overhead? Yeah, there's a lot more overhead, right, in a TCP. By the way, these are all referenced, so if you go download this. DHCP is UDP. I'm actually not 100% sure. We can go check real quick. Because we have, in my home lab, file opens, just go look at one of my Kali boxes. I should be able to find some DHCP in here. Pretty sure. Might not have had any boxes coming up during this. Probably, well, so, by the way, DHCP is operating at layer 2, but, I should be able to filter this. Yeah, I don't have any DHCP in here. So, yeah, DHCP, by the way, strictly speaking, is operating at layer 2, though, and it's just broadcasting all Fs in the MAC address. But, I mean, I guess, you know, it's probably still got some other stuff attached to it. We can go look at that if we can go find one. I can look on my system and reboot some stuff if we wanted to. But anyways, then we have, so that's the headers. The headers are important to know. You can go see all of this stuff inside of a, you know, we can come right here and we can go look at a TCP header. And here's all the TCP information in the same order that's over there. And then there's we can go look at like a UDP session. UDP would be, I have some that are UDP. If we went back to my module 5.1. So these are all UDP, even though they're session initiation protocol and then real-time transport protocol, but they're UDP under the hood. So UDP is very short. That's the whole header right there. That was the whole header. You see it on the right there. That's the whole header. Nothing. Right there. When we're looking at it, it shows the whole thing. Yeah, there's the whole header right there. It's almost nothing compared to one of those TCP ones, which were much more. So this is a phone call specifically, and I can actually play it. This one always bugs me. Ugh. This one bugs me a lot. Go VoIP, and then can I play this? Oh no, that's not the right one. that's not the right one. It's on my other one, but it's like a super creepy hello world. That's like the most annoying voice most like disjointed, soulless voice I think I've ever heard. Darsh said, "I don't want to be negative, but I feel like the 5-layer OSI model can still work." Yeah, it's fine. I think it's still useful. What you got there, wifey?
I don't know, something.
Wifey's
You
got
ordered.
stuff. Well, let's check it out. Let's see what kind of stuff we got. All right, guys, I got to get off of here. This is recorded up on the YouTube side from before when I first did it, and we went through everything. I need to add more to this, and I do need to keep working on it, but we'll call it here. I knew I wasn't going to be able to stream too long tonight, but I appreciate you guys all coming by. I will see some of you guys later on in the week, and we will keep going through this stuff. But again, this is all up there.